Good morning, Algebra 2. Hope you guys are doing well. So we're going to continue with our statistics unit, and we're moving on to theoretic probability. So first we're going to start off with some vocabulary. Probability is just the measure of how likely it is for an event to occur, and what are the chances of something happening. Okay? So a few other vocabulary notes. The set of all possible outcomes is called our sample space. So that's just how many total things could possibly occur. Okay? For equally likely outcomes, the theoretic probability of an event, P of E, is just going to be the ratio of the number of favorable outcomes, so that's, whatever we want happening, to the total number of possible outcomes. So let's look at some simple ones to start off. Here we have a jar contains 32 red marbles and 28 blue marbles. What is the probability that a randomly selected marble is red? In a scenario like this, we know that there are 32 red marbles, so that's going to go on top for our ratio, and then on the bottom we're going to have the total number of marbles, which is 28 plus 32, or 60, because that's kind of the total possible ways that we could grab a marble. There's 60 different options: 32 red, 28 blue. When we're doing these ratios, you always want to actually reduce these guys down. 4 goes into both these numbers, so I'm going to divide both of them by 4, and I get something like 8 over 15. So that tells me there's an 8 in 15 chance that I choose a red marble. All right. Let's move on to number 2. A letter in the word restoration is randomly selected. What is the probability of selecting a vowel? So a vowel is E, O, A, I, and O. So I have 1, 2, 3, 4, 5 vowels out of the total number of letters that I could possibly choose are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's a 5 in 11 chance of selecting a vowel. Right? Sometimes things will get a little more interesting, like here we have a day in the month of January is randomly selected. What is the probability of selecting a prime number? Okay, so we know there are 31 days in January, so that's going to be our total, and then we have to count up all the prime numbers. So 1 is never considered prime, but we had 2, 3, 5, 7, I think we got 11, 13, 17, 19, 23, 29, and 31. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 and 31 chance. Okay? Sometimes we're going to even have to use our skills that we learned in our previous lessons. For example, here we have 2 dice are rolled. What is the probability that the sum of the 2 dice on the next roll is at least 9? Okay, so in this scenario, we have 2 dice are rolled. There's 6 options on each of those die, right? So our total different options is going to be 6 times 6. We're going to have 36 total possible outcomes. And then we got to think, what is the probability that the sum of the 2 dice on the next roll is at least 9? Right? So all we have to do in order to figure that out is see how many of these guys could end up being 9. We're going to do a little bit of side work here. We got 1 and 1, that's 2, right? If we have 1 and 2, that's 3. 1, 3, that's 4. 1 and 4 is 5. 6. 7 is 8. 1, 8 is 9. So all these guys, right, ended up giving us something 9 or below. Right? But then we had that, that 1 and 6 right there is the max that we're going to be able to go, right? 1 and 6 is 7. Right? And then as we continue on, we'll see that we actually, I'm not going to do all the work just for the sake of time, but we can actually nix all the ones that are below 8, or 8 or below, and the ones left are going to be 10. Right? There's going to be 10 different options that will give us at least 9, and then we can just reduce this guy because 2 goes into both them, and we have a 5 and 18 chance. Right? So next up, what is the probability of drawing a heart or a club from a standard deck of cards? So a standard deck of cards has 52 total cards, and there's 13 hearts and there's 13 clubs. So that's a total of 26. So we have 26 and 52 chance, which reduces down to 1 over 2. Right. Next up, there are 8 books lettered A through H on the shelf. If Scott randomly chose 2 books, what is the probability that he chose books A and B? So in this scenario, we're going to actually have to go ahead and look back to what we learned about permutations and combinations. Okay? And in this case right here, okay, we have one scenario that we want to happen. We want him to choose book A and B, but now we have to think about all the possible scenarios that could occur here. And he has 8 things to choose from. Order doesn't matter, and he's choosing 2 of them. So in this case, I actually ended up having a combination in my denominator to figure out the total. So we're going to do all our little side work here. Okay, remember, that's just going to be 8 factorial over 2 factorial over 8 minus 2 factorial. And that gives us something like 28. So we get 1 over 28 as the chances of that occurring. All right, so we're going to talk about one more thing in today's lesson, and that's the complement of an event. And that is just the chances of an event not happening. Right? And since the sum of all probabilities in a sample space is always going to be 1, which means that, you know, if we were to say, hey, what's the chance of anything happening? Something's gonna happen. So there's a 100% chance. We just call it 1. Right? So in that scenario, right, if we want to check out the chance of something not happening, which is notated like that right there, we just do 1 minus the chance of it happening. Right? That will give us the chances of something not occurring. So for example, the probability that it will snow tomorrow is 7 out of 20. What is the probability that it will not snow? So all we'd have to do is do 1 minus 7 over 20. Okay? We do have to rethink that 1 as 20 over 20. So we can actually go ahead and combine those guys. We have to get a common denominator. All right, number 8, we have a month of the year is randomly selected. What is the probability of getting a month that does not begin with the letter A? All right, so in this scenario, we have to first think, hey, how many options are there that begin with the letter A? I think it's just April and August. So there's a 2 out of 12 chance that it does begin with. Sorry, guys, I was interrupted by a call. So let's just continue here. So we were just talking about number 8. So we said that there are 2 months out of 12 that begin with the letter A. But remember, we're trying to figure out what is the probability of getting a month that does not begin with the letter A. And remember, that means we're trying to find the complement, where we take 1 and we're going to subtract that guy away. So 1 minus 2 over 12, we got to kind of rethink of it as 12 over 12. That's just me rethinking the 1 with a common denominator. Then we get 10 over 12, which reduces to 5 over 6. Yeah. So go ahead and try numbers 9 and 10 on your own. Pause the video and then unpause it when you're ready. So this one says, if the spinner to the left is spun, find the probability that it lands on a number that is not prime. So first off, we have to think about the potential prime numbers here. Okay, so we have 2, 3, 5. So here, let's keep count here. So that's going to be 1, 2, 5, 7, 11, 13. Okay, so 1, 2, 3, 4, 5, 6. It looks like, right? So we have 6 prime numbers, and let's see, that means that 10 out of the 16 are not prime. Right? And what we can do here, so what we can do here is take that 6 out of 16, I kind of already did the problem right there, and subtract 1 from it. So we got 1 or 16 over 16 minus 6 over 16, and we get 10 over 16. That's the chances that it is not prime. Okay? And finally, we have 2 dice are rolled. What is the probability of not getting doubles? So in this scenario, we have to do a little side work. Remember, there's 6 different numbers on the first die, 6 on the second, so there's 36 total options or combinations that we might have. And if you think about it, the probability of getting doubles, that's like 1 and 1, 2 and 2. There's only 6 scenarios where that's going to occur. So that's 6 over 36 are the chances of getting doubles. But we're trying to figure out where the probability is not of getting doubles. So we're going to take 1 and subtract it. So I got 36 over 36 minus 6 over 36. And that guy reduces. I think 6 goes into both of them. So we got 5 over 6 as our answer for that guy. Okay, so for homework, I want you to flip over to homework 2. Okay, and let's have you guys just do the odds up to 11. So the odds up to 11 on homework 2.